In this videotape, we will present the second half of our pre-calculus final review. Question 1. Write an equation of a line which passes through the point 1 minus 1 and is perpendicular to the line 2x minus 4y minus 3 equals 0. We can make a rough sketch of this. We have this straight line. If we find the intercepts, we can, for example, set y equal to 0 and get 2x equals 3, x equals 3 halves and 1 1/2. So that's so. If x equals 0, 4y is equal to minus 3, y is equal to minus 3/4. So around here, we have a line that looks something like this. And we have a point, 1 minus 1, which is not on the line. We would like to find the line which passes through that point and is perpendicular to the given line. That is, we'd like to find the equation of this dotted line, which is perpendicular to the heavy line. You don't have to graph this. I'm just trying to help you visualize it. Okay, now this is the line 2x minus 4y equals 3. We want to find the equation of the dotted line. Okay, now to find the equation of a line, we need point and slope, and then we could use point-slope form of the equation of the line. This is a line through the point x1, y1 with slope m. And we need the slope of the dotted line. But since it's perpendicular to the heavy line, its slope will be the negative reciprocal of the heavy line. So it basically comes down to a problem of finding the slope of the heavy line. Now to find the slope of this line, 2x minus 4y equals 3, the best thing to do would be to put it into y equals mx plus b form. That is to solve for y, get y alone on one side of the equation. So let's see, we have minus 4y is minus 2x plus 3, subtracting 2x from both sides, and dividing by minus 4, giving us y equals 1/2 x minus 3/4. Okay, from this, matching it up to y equals mx plus b, we see that the slope of the original given heavy line is 1/2. Therefore, the slope of the line, the slope of the dotted line, which is perpendicular to it, is minus 2, negative reciprocal of 1/2, negative and reciprocal. Okay, so the slope of the dotted line is minus 2. It goes through the point 1 minus 1. So letting this be x1, this be y1, and substituting into the point slope form of the equation of the line, we get y minus 1 is the slope, minus 2 times x minus x1, or x minus 1. Y plus 1 is minus 2x plus 2. And you can subtract 1 from both sides, giving you y equals minus 2x plus 1. As one of the ways you can present the answer, you could have also had said 2x plus y minus 1 equals 0, the general form of the equation of the line. Either way would be acceptable. Okay, question number 2. Write an equation of the line which passes through the points 7 minus 4 and 7 3. Okay, now if the line is not vertical, you can of course find the slope of the line and use either point in the point slope form of the equation of the line. However, if we plot these 2 points, we see that we have 7 minus 4. Here's 7 minus 4. And the other one is 7, 3. And they do, in fact, lie on a vertical line. The equation of this vertical line is, of course, of the form x equals a constant, and it would be just x equals 7. The x-coordinate of all points on this line is 7. Okay, if you did not make the picture and you tried to find it, by doing point slope, and you worked out the slope, you would get y2 minus y1 over x2 minus x1. The difference in y over the difference in x, the denominator would be 0, 7 minus 7. You'd have division by 0. You'd say the slope is undefined, and that would remind you that it's a vertical line. Vertical line has slope which is not defined. Okay, so if you didn't sketch it and you saw it that way, then when you worked it out, you would notice it there. Okay, prove that the points 0, 3, 1, 1, 5, 3, and 2, 4 are the vertices of a trapezoid. Which contains a right angle. Okay, let's label these A, B, C, and D, and let's plot them. Okay, 0, 3 is over here. Here is point A. B is 1, 1. C is 5, 3. 1, 2, 3, 4, 5. 1, 2, 3. C is 5, 3. And D is 2, 4. And the figure looks like this. We want to show that this is a trapezoid which contains a right angle. Okay, trapezoid, we have a quadrilateral here. Trapezoid would be a quadrilateral that had two sides parallel. Okay, so we're looking to show that two sides are parallel. From the picture, it looks like we're trying to show that AD is parallel to BC. And we'll do that by finding the slope of AD and the slope of BC. And if we can show that they're the same, then AD would have to be parallel to BC. Okay, the slope of AD. Here is A, and here is D. y2 minus y1 over x2 minus x1. It doesn't matter which you call your first point, which you call the second, but of course you must subtract in the same way. So if I go 4 minus 3, AD. 4 minus 3 for y2 minus y1 over x2 minus x1. 2 minus 0, I have 1/2 for the slope of AD. Similarly for BC, 3 minus 1 over 5 minus 1. That's 2/4, also 1/2. So since the slopes are equal, AD must be parallel to BC. And therefore, ABCD is a trapezoid. Now I'm looking to show that there is a right angle in this trapezoid. Let's see, we know the slope of BC is 1/2. Looks like it might be a right angle over here, so let's work on that. Let's look at the slope. Let's find the slope of AB. If we could show that was a negative reciprocal, the slope of BC, we would show that angle B is a right angle. Okay, so the slope of AB is 1 minus 3 over 1 minus 0. 1 minus 3 over 1 minus 0. y2 minus y1 over x2 minus x1. That gives us minus 2. All right, since the slope of AB is minus 2 and the slope of BC, let's say, is 1/2, they are negative reciprocals, we say that AB must be perpendicular to BC. Since they're negative reciprocals, their slopes, or the product of their slopes, is minus 1. Minus 2 times 1/2 would give us minus 1. So that means that angle B is a right angle. So we do have a right angle here. By the way, AB is also perpendicular to AD. Since AD and BC here are parallel, they have the same slope. So you could have also shown that. We've also shown that angle A is a right angle. So we've shown it's a trapezoid which contains a right angle. Okay, in 4, we are given these functions. F defined this way, f of x is x squared minus 4x, and g of x is the square root of x plus 3 over the square root of x minus 5. And we are asked to find various things. We are asked what is, in A, f of minus 2 plus g of 9. And then later in B, we're asked for f of x plus 2. All right. You have to understand what these functions do. F of x is x squared minus 4x. F of 3 would be 3 squared minus 4 times 3. F of anything is that something squared minus 4 times that something. F of anything is that something squared minus 4 times that something. Whereas I can rewrite the f function with parentheses wherever x was. Then if you want to know what f of minus 2 is, you simply substitute in minus 2, and you say f of minus 2 is minus 2 squared, that's 4, plus minus 4 times minus 2 is plus 8. So you get 4 plus 8, or 12. Similarly, let's look at the g function. You put in a value, it takes the square root, it adds 3 to it, and divides by the square root of 5 less than the number. So, particular g of anything would be the square root of that something plus 3 over the square root of that number minus 5. Now we're interested in g of 9, so we simply fill 9 into the parentheses. And we have the square root of 9, which is 3, 3 plus 3 over the square root of 9 minus 5 over the square root of 4. That gives us 6 over 2. That's the positive square root of 4, which is 2, and that gives us 3. So for f of minus 2 plus g of 9, we have 12 plus 3 for a final answer of 15. Now, let's remember here that f of x is x squared minus 4x. F of anything is that something squared minus 4 times that something. So f of x plus 2, you just fill x plus 2 into the parentheses. X plus 2 squared minus 4 times x plus 2. And then if we want to simplify this, we say this is x plus 2 squared is x plus 2 times x plus 2 minus 4 times x plus 2. Multiplying this out by FOIL, x squared plus 2x plus 2x plus 4x plus 4, and distributing the minus 4, minus 4x minus 8 gives us x squared plus 4x, and the minus 4x cancel each other out, plus 4 minus 8, 4 minus 4. Final answer of x squared minus 4. Okay, in question 5, let f of x equal the square root of x plus 3. We want to find in A the domain of f and in B to compute f squared of 6. Okay, the domain of f would be the set of all those x values for which this function would make sense. Okay, we wouldn't have any division by 0, well, in this case there's no fraction, but if it was a fraction we'd worry about division by 0. With a square root we'd worry about square roots of negative numbers. Okay, so all the x values for which this would make sense would be those x values for which the quantity under the radical was non-negative. Otherwise you'd have the square root of a negative number. So x plus 3 must be greater than or equal to 0, or x is greater than or equal to minus 3. This can be indicated. Okay, the domain is a set, either the set of all x values such that x is greater than or equal to minus 3, or in interval notation, minus 3 to plus infinity. All x values starting at minus 3 and all the way up. If this had been a parentheses instead of a bracket, that would be greater than minus 3. With the bracket, it's greater than or equal to minus 3. Okay, f squared of 6. This means f squared of 6 means f of 6 times f of 6. It's f of 6 squared. Okay. So as you find f of 6, and we will square it. Now, what is f of 6? F of anything is the square root of that something plus 3. So f of 6 is the square root of 6 plus 3. F of 6 is the square root of 6 plus 3, the square root of 9, or 3. So if f of 6 is 3, then this is simply going to be 3 squared, or 9. In problem 6, okay, the next few problems deal with logarithms. In 6, we want to find y such that the log of 81 to the base 27 is equal to y. Now, in working with logarithms, we need to remember the basic definition. When I say that y is the log of x to the base b, this is equivalent to saying that x is equal to b to the y power. That is, the y here is the log of x to the base b. The log is the power that you'd have to raise the base to get the number here. Okay, so if I have that y is the log of 81 to the base 27, this is equivalent to saying that 27 to the y power is equal to 81. The log is the power that you'd have to raise the base to get the number. So we have to solve this equation here. And if you remember our work on solving equations of this form, the trick is to try to get the same base on both sides, and then we can just equate the exponents. Well, 27 happens to be 3 cubed, and 81 is 3 to the 4th power. So 3 to the 3y is equal to 3 to the 4th power. Now, if these are equal and the bases are equal, the powers must be equal, the exponents must be equal. 3y must be equal to 4, y must be equal to 4/3. And you raise 27 to the 4/3 power, you would get 81. 27 to the 4/3 power means the cube root of 27, which is 3, raised to the 4th power to give 81. In problem 7, find x such that the log of 4x plus 1 to the base 3 is equal to 2. Well, this is equivalent to the following. If I say the log of 4x plus 1 to the base 3 is 2, that means 2 is the power that you would have to raise the base 3 to get this number 4x plus 1. So we have that 9 is equal to 4x plus 1, subtracting 1 from both sides. 8 is equal to 4x, dividing by 4, x equals 2. 2 equals x, or x equals 2. That is, log of 9 to the base 3 is 2, because 3 squared is equal to 9. In problem 8, find x such that the log of 81 to the base 3 equals 3x minus 2. This is equivalent to the following. 3x minus 2 is the power that you'd have to raise the base 3 to get 81. Okay, trying to get the bases to be the same on the left and the right. 3 to the 3x minus 2 power is 81, which is 3 to the 4th power. And now we equate the exponents. 3x minus 2 is 4. Add 2 to both sides. 3x equals 6. Divide by 3. X equals 2. 3x minus 2, 6 minus 2 is 4. The log of 81 to the base 3 is 4, since 3 to the 4th power is 81. In problem 9, in part A, we want to simplify completely the following. Log of the square root of x cubed y over z squared. We want to use the properties of logarithms in this case. This log, when there's no base mentioned, it means log to the base 10. Okay. First of all, we can say here that the log of a fraction is the log of the numerator minus the log of the denominator. And then we can say x cubed y, square root of that is just x cubed y to the 1/2 power. So we said the log of a fraction is the log of the top minus the log of the bottom. And now I want to use another property of logs, which says the log of something to a power is the power times the log of the something. That is, we can bring the power down in front as a coefficient. This gives us 1/2 the log of x cubed y minus 2 times the log of z, in both cases bringing the power down in front. Then I want to use the property that says the log of a product is the sum of the logs of the factors. So this is 1/2 the log of x cubed plus the log of y and minus 2 log z. Don't forget to keep the 1/2 out in front. It has to be distributed through the parentheses. Okay, and the last thing I want to do here is this log of x cubed. I like to bring this 3 down in front as a coefficient. So I have 1/2 3 log x plus log y minus 2 log z. And you can distribute the 1/2 to give us 3/2 log x plus 1/2 log y minus 2 log z. That's our final answer. In 9b, we're asked to write in scientific notation $54,700. Okay, by that we mean write this as a number between 1 and 10 times 10 to some power. It's scientific notation or power of 10 notation. Okay, now, we therefore would write this as 5.47. That's a number between 1 and 10, times 10 to some power. Got to figure out the power. Now, when you multiply by 10 to a power, and the power is a positive integer, that moves, say, a positive integer p, that moves a decimal point p places to the right. If it was a negative integer, okay, negative integer p, it would move For example, like -5, we would move the decimal place 5 places, decimal point 5 places to the left. So negative, you move to the left, positive power, you move to the right. Okay, so we want to get this number. So we have 5.47. We want to move the decimal point 1, 2, 3, 4 places to the right. So then this should be written as 5.47 times 10 to the 4th power. This will move the decimal 1, 2, 3, 4 places to the right, giving us 54,700. Okay, in problem 10, we want to use the properties of logarithms to express as a single logarithm the following. 1/2 log x plus 2 log y minus 3 log z. Okay, let's just go back a moment to problem 9a here. See, in 9a, we were given it as a single logarithm and used the properties of logarithms to expand it in this form. Okay, now we're given it in this form. We want to use the properties of logarithms in reverse to get it back to a single logarithm. Same properties that the log of a fraction is the log of the top minus the log of the bottom. The log of a product is the sum of the logs of the factors. The log of something to a power is the power of the times the log of the something, but used in the reverse order. So now let's go back over here. Okay, so to begin with, this time I'm going to take the coefficients and move them back upstairs as powers. So I'll write this as log of x to the 1/2 plus the log of y squared minus the log of z cubed. So log of x to the 1/2 plus the log of y squared minus the log of z cubed. Okay, that's 1/2 log x plus 2 log y minus 3 log z. Now I can say that the sum of the logs here can be written as a log of the product of x to the 1/2 times y squared. Let's write x to the 1/2 as the square root of x. So we have log of the square root of x plus the log of y squared. The log of a product is the sum of the logs of the factors. And then finally, since we know that the log of a fraction is the log of the numerator minus the log of the denominator, we can write this as the log of the square root of x y squared over z cubed. This we now have the log of the top minus the log of the bottom. This breaks down into the sum of the logs of the factors. The powers go down, and we're back where we started. So we have written it as a single logarithm. The next few problems deal with trigonometry. Problem 11, we want to evaluate trig functions of various basic angles. A, B, C, and D. We have the sine of pi over 4, the cosine of 120 degrees, the tangent of 330 degrees, and the cosine of 3/2 pi. Okay, to begin with the sine of pi over 4, well, we can think of this as, if we want to switch it from radian measure to degree measure, we multiply by 180 degrees over pi. Pi's cancel, and we get that this is equal to the sine of 45 degrees, which we can then get from a 45, 45, 90 right triangle, an isosceles right triangle. Let's say this has length 1, length 1. This is a right triangle, 45 degrees, 45 degrees. The base angles are the same here because it's isosceles. This would have to be by the Pythagorean theorem, the square root of 2. So the sine of 45 degrees, opposite over hypotenuse, 1 over the square root of 2. Or if you want to rationalize this, you can multiply top and bottom by the square root of 2 and get the square root of 2 over 2. So either 1 over the square root of 2 or the square root of 2 over 2. Okay, cosine of 120 degrees. Now, for angles outside of the first quadrant, we try to find the acute reference angle that corresponds to it. In the second quadrant, we subtract the angle from 180 degrees, and we get the reference angle here is 60 degrees. So it's going to be plus or minus the same trig function, that is cosine of 60 degrees. Now, where the plus or minus sign is determined according to the following chart. All students take calculus. This means that all the trig functions are positive in the first quadrant. Sine and its reciprocal cosecant are positive in the second quadrant. Tangent and its reciprocal cotangent are positive in the third quadrant. Cosine and its reciprocal secant are positive in the fourth quadrant. So, we're talking about the cosine of an angle in quadrant 2. It's quadrant 2. Cosine in quadrant 2 is negative. Sine and cosecant are positive. So therefore, it's going to be negative cosine of 60 degrees. So negative, now we need the cosine of 60 degrees, so we go over to our 30, 60, 90 right triangle.